Scholar, section 6.2 deals with the rational exponents. This is critical that we always remember. We use this a lot in math courses in general. Every time I see my exponent that is a fraction, I need to think of radicals. We always make that connection. Fraction, if an exponent that is a fraction equals radicals. So if I have a raised to the 1 to the nth, that will be the nth root of a. So if I have x to the 1/2, that's the square root of x. X to the 1/3, that's the cube root of x. X to the 1/4, that's the fourth root of x, etc., etc., etc. Okay, so the denominator becomes the index. That's fully written. So let me write this again. So if I have x to the 1/2, that will be the square root of x. Of course, we don't write the 2. If I have x to the 1/3, that will be the cube root of x. X to the 1/4, the fourth root of x, etc., etc. We can also expand the rule. If I have a raised to the m over n, now the denominator becomes the index, the numerator becomes the exponent. Okay. If that exists, if we don't violate any rule here, if I can find the nth root of a, then we can afford to pull the exponent outside. What do I mean? If I have, for example, 8 raised to the 2 to the 3, okay, my exponent is a fraction, so I need to think of radical. My base becomes my radicand. My denominator 3 becomes my index. And in theory, the 2 goes here inside. So it will be the cube root of 8 squared, which will be 64. The cube root of 64 if I were to put the 2 inside. But we can ask ourselves, it is possible to find the cube root of 8? The answer is yes. The only thing that we cannot do is if I have a negative number and an even, let's say 2 or 4, 6, that's when we have an issue. Okay? But here this is fine, so we can afford to place the square outside. So now it's easier. Now we can do the cube root of 8, which is 2, and then the 2 we raise the square, so this will be 2 raised to the 2, which is 4. Otherwise, we have to deal with the third root, the cube root of 64, which is not bad, but sometimes numbers becomes too big. Be the answer. Okay. If I have 16 raised to the 3/4. Okay, so exponent is fraction, so I need to think of this guy. 16 is my radicand, the 4 is my index. Before I place the 3 inside, well, the 3 should go here, for example, but now I have to do 16 times 16 times 16, and then take the fourth root of that. So I can ask myself, can I find the fourth root of 16? Yes, we can. Even though this is even, my radicand is positive, so we are safe. Okay, so we can afford to place a 3 outside. Because now it's easier to find the fourth root of 16, which is 2. If I take 2 and multiply by 4, if multiply by itself 4 times, it will give me 16. So it will be the cube root of 16 is 2, but that chunk is raised to the 3, so it will be 8. Okay. Let me check this. Chapter, section 6.2, rational exponent. So this is the first rule, 8 to the 1 to the nth. And we have here several examples, of course. I'll cover this very soon. So this will be the fourth root of y, number 1. Number 3 will be the fourth root of 16. Number 5, let me just erase this. Number 2, well, since I have the parentheses, that means that the 3a is inside the square root. The 2 goes here and the 1 inside. We don't write the 2. Okay. Number 4, that will be the cube root of 125. Number 5, that will be the fifth root of what? Of a cube b squared c to the 1. Okay, going backwards, of course, number 6, if I have the cube root of 19ab, this is, I have to use the parentheses, 1919 ab, and this chunk is raised to the 1/3. Okay, this is an invisible one inside, and the 3 is the index. This is 1/3. So look at number 9. The 7 is outside, so we have 7 times the fourth root of 2ab. Okay, so we leave the 7 by itself, parentheses, 2ab raised to the 1/4. And then, of course, we can expand the rule, a to the m over n. So that's that. Okay. Let's see what else is in here. A matter of getting used to it. We need to evaluate. So I already did that. Let's look at number 12. And here, 4 raised to the 5/2. And so this will be the square root. We don't put the 2, I just put it there, 4. Now, the 5 should go here. I mean, I need to do 4 raised to the 5, multiplied by 4 by itself 5 times, and then take the square root. Kind of painful. It's better just to find the square root of 4, which we know is 2, and then we raise it to the 5, which is 2 to the 5, which will be 32. And we're done. And working backwards, of course, if I have the cube root of 7abc, and that is raised to the 4, well, I know that would be 7abc, and the exponent is going to be what? The index is 3, so it becomes the denominator. The exponent is 4. That's it. Sorry for the bus pause there. I thought I paused the video while I erased and wrote the next rule. So I'm going because otherwise I had to record the whole thing. So I do apologize. I just paused the sharing, not pause the recording. So they said we are gap in between. I do apologize. Okay, so the negative exponents, we don't like negative exponents. A to the negative n is 1 over a to the n. So if my exponent is a fraction, well, we do the same thing. So if I have, let me share the screen. So let me just do this. If I have a to the negative, if I have 25 raised to the negative 1/2, we don't like negative exponents, so what do? We send it to the denominator. That will be 25 to the 1/2. But I know that 25 to the 1/2 is the radical 25, which is, of course, 1/5. So it's the same, but now if it's negative, we have to move it to the denominator. Let me share the screen. Negative exponent, okay. Okay, so we have several examples here. Let's see what we have. Okay, the interesting one to do. Okay, worked out. I kind of, uh, I did this one. I should have paused the video. Let me just go to the problem. I'm sorry, folks. Okay, I think I did the same thing. I thought, okay, so let's work on these three problems. I believe I'm still sharing. Yes, and I'm recording. I hope. Let me see. Stop sharing, and I'm still recording. Yeah. Okay, so this is going to be very weird, very weird recording. I do apologize. Come on, Miguel. Okay, let's go ahead and share this. Okay, so I have these three problems from the book I made of this guy. And that's it. Okay, so I need to do also number 32. That is a 2ab over 3c raised to the negative 5 over 6. Okay, let me stop sharing this. Okay, so this is the exponent is negative. Of course, that would be 1 over 16 to the 3 over 4, which is 1 over 16. My index is 4. Yes, I can find the fourth root of 16, which is 2. So that would be raised to the 3. This is 1/2 raised to the 3, which should be 1/8, and we are done. This one, be careful, folks. I do not have a parenthesis, so the negative 1/4 only applies to the x. So the 3 is half in the numerator, and we just simply move the x to the denominator as x to the 1/4. This is the same thing as 3 over the fourth root of x. If I have a parenthesis, now I move everything to the denominator 1 over 3x to the 1/4. Since I have the parenthesis, now the 3x goes inside the radical. Okay, and let's do this guy. 2ab 3c, 2ab 3c, 2ab 3c to the negative 5, 6. Okay. So what do I have here, folks? This is the same thing as what? 1 over 2ab over 3c raised to the 5 over 6. But the reciprocal of this will be the other way around. It will be that will be 3c over 2ab raised to the 5 over 6. We just simply take the reciprocal. Okay. I run out of space on this one, so let me just do it properly. I will finish that one, with the rest of the problems that I have for you later on. Thank you.